So greetings students. So this lecture it's all about the continuation of the previous problem. So the previous problem we have started with your bus building algorithm. So in the bus building algorithm there exist nearly four types. Okay, so our ultimate aim is to build your Z bus from your single line diagram. So here they have asked to determine the Z bus from the system and they have given your reactance value. So this is a reactance diagram, and so as the diagram suggests, it is very clear that it is a three bus system. It is a three bus system. Also it has a reference bus. It is connected to a reference bus. Okay, so here you might be asking, sir, whether you have to consider this reference bus as a separate bus and you have to take this to be a four bus system, you might be asking. But it's like that. This reference bus, it's not a part of this system. Okay, from this reference bus only, you are connecting all the other buses. Yet, this is not the part of this system. You have to consider this to be a three bus system. So there will be a numbering. So you have to see as the number suggests. Okay, so the highest number suggests your total number of buses in this particular system. So moving on, we started step one. So as per your step one, we will be connecting a new bus. A new bus, as I said, you have to move always from your left side to your right side when you are seeing your system. If they didn't give this numbering, okay, in some cases they won't be giving this numbering. If they didn't give the numbering, means what you have to take is you have to always number from your left hand side to your right hand side. Okay, so if you're numbering from your left to right, so this comes 1, 2 and then 3. And similarly you will be attaching your first bus to your reference bus over here. Okay, so it is of reactance value of j 1.2. We are just attaching. So this comes under the criteria of attaching a new bus to your reference bus. So you'll be directly writing your impedance value over here. So here, as I said, how you can cross check means you can cross check by this. So now this is a 1 cross 1 matrix. It is a 1 cross 1 matrix, and here a single bus is attached to the reference bus, and hence your total number of buses and the matrix size are same. Okay, you have to always cross check this. It is a very important criteria. So now we have attached your first bus with the reactance value of j 1.2 to your reference bus. Okay, and next you will be moving towards the second part. Okay, second reactance or the second bus. As I said, you will be moving from your left to right. So you'll be moving from your first bus towards your second bus. Okay, you're moving towards the second bus. So the impedance value what it is attached is, it is j 0.2. So j 0.2 acts as a new bus, whereas your first bus and the connected reactance will be acting as an existing bus. Okay, so as per this, you have to directly put your old bus value over here, and after that, for the diagonal element, you will be adding the new element with the existing element. Okay, we'll be adding with this the new element. Okay, with the existing element you'll be adding this. So now we'll be getting your diagonals. Okay, so after this you have to over here, what you have to do, you have to put the value which is to the nearer column. So the nearer column value is your j 1.2. So the same value will be coming over here as well as over here. Okay, so this is the methodology involving your bus building concept. It is very simple concept. Easily you can grasp it. Okay. The main particular thing you have to check is always you have to check is the matrix size. Okay, the matrix size must be equal to the total number of buses. This is a mandatory condition that you have to check in each and every step. Okay, at each and every step it is compulsory to check this condition. So over here the matrix size is same as that of here number of nodes, okay, number of buses, and hence you can just move on. So this is your Z bus. After adding these value, you'll be getting around J 1. Okay. So now moving to the third step. The third step, the thing is that, as I said, you'll be moving from your left to right. So after the second one, you'll be moving to the third one, and this J 0.1 coming as a new reactance, and here it is the new bus. So the bus 1 and the bus 2 remains to be an existing system or the existing bus, is connected to your and the third bus is connecting to your existing system. Okay, and as per the criteria, what happens, you have to directly write your existing bus. So the existing bus directly will be coming from over here to here. So after that, you have to get with respect to a diagonal. So as per the diagonal, the element at this point will be added with your new Z bus. That is new reactance value. That is ZB. So your J 1.4 plus J 0.5 will be adding. So other things are the same as that of your step 2. That is, you will be writing the value of the previous column and the previous row in the next thing. Okay. So and again here we have to make a cross check that the number of buses are equal to your size of the matrix, and as per the condition your number of buses is 3 and the size of matrix is also 3 cross 3. So the condition is satisfied. So now moving. So this is the Z bus after the addition part. Okay, addition part will be getting J 1.55. So up to this we have covered in your last lecture. So in this lecture, we'll be moving towards the next step. Okay. So as per the next step, here you have to see the third bus. It is this bus. That's this reactance is added to your reference bus. Okay. First, you have to complete all the reactances or the impedances which is attached to your reference bus. Okay. After moving through your buses, and as per the it so your J 1.5 remains to be your new bus, which is added to the existing bus of these things. Okay, these reference bus 1, bus 2, bus 3 remains your existing bus, and this J 1.5 remains to be your new bus. Okay, and hence this is your Z bus old matrix, and this Z bus old matrix will be directly coming into this part. Okay, this part is your Z old matrix. Okay, this entire part, and after this the same thing you have to do. So over here J 1.5, that is this value gets added with your new reactance value. So if you're adding, it will be coming and like this, and after that the same thing with respect to step 2 and step 3. So the column of this value gets repeated over here, and the row of this value gets repeated over here. Okay, so compared to your Y bus, the formation of Z bus matrix is very easy. Okay, it is very easy to understand also. So after this, you will be getting the matrix in this format. You'll be getting the matrix in this format. Okay. Now, if you're cross-checking means, now here comes the different part or the tricky part. The thing is, over here your matrix is a 4 cross 4. It is a 4 cross 4 matrix, but the number of buses exist over here is a 3. Okay, and what happens? The matrix size exceeds your number of buses. Okay, your matrix size exceeds the number of buses. Okay, so what you have to do is you have to apply node elimination method. So here comes the concept of node elimination. So the system is a 3-bus system. Okay, but the impedance matrix is a 4 cross 4 matrix. Okay, so here comes the variation. So it is necessary to apply the node elimination method.
So in this one, sir, we are having impedance between 1 and 3 buses, no? So we haven't included that one.
Yeah, I'll be just saying, ma'am. We have to add that also. That is your step 5. That comes with your step 5. After completing the step 4, I'll be saying. Okay. So you have to add that also. But before that, if like this condition arises, that is your matrix size is more than your bus size, means first of all you have to reduce it within that step itself. Okay, so it is necessary to reduce this matrix within this step 4. So after that you have to move towards your step 5, that is adding another one impedance. Okay, so now we have to apply the node elimination. So node elimination method, there's a formula. Okay, there's a reduction formula, Cron's reduction formula. So that Cron's reduction formula I have given your Zibus algorithm lecture, that you can just refer it. So this is your Cron's reduction formula. So it's a very easy formula to have in mind also. So this is a JK actual. Okay, is what we'll be finding. That is for your 3 cross 3 matrix you'll be finding. So now our ultimate aim is to reduce this 4 cross 4 matrix into a 3 cross 3 matrix. Okay, so that exists our ultimate aim. So as per it, so for the ZJK actual will be equal to ZJK, that is the value at that matrix, particular matrix, followed by okay. Okay. Followed by, this is the formula, Zj n plus 1, Zn plus 1k divided by Zn plus 1 and n plus 1. These are the subscripts represents your elements. So here, as I said in the first introductory part itself, here the number of bus over here is 3. So J value exists up to your 3, 1, 2, 3. Okay, we are going to find for a 3 cross 3 matrix. So the elements will be 1, 2, 3, and for the K value also it will be 1, 2, 3. Okay, so now we will be applying for Z11 actual. So over here, if you are applying Z11, so directly you can apply it. So here for the first one, so here J value is 1, K value is 1. If you are applying means, so JK, the same value will be coming. Okay, so that is, this is the value which you have to take from this point, from this matrix. That is your 4 cross 4 matrix. This is the value with respect to 4 cross 4 matrix, but this is the value with respect to your 3 cross 3 matrix. Okay, minus of Z14. Okay, this is as per the formula, it is Z14. J value is 1, N value is 3, so N plus 1 will be 4. Followed by Z N plus K, it is 4, N plus 1 is 4, and K value is 1 divided by, over here you will be writing N plus 1 and N plus 1, it will be 4. Okay, and now we have to map the elements from this 4 cross 4 matrix. So J 1.2 is your Z11, and Z14 is your J 1.2. Okay, and then again Z41 is J 1.2. Okay, this value and followed by this value, and finally Z44 is J 3.05. Okay, you have to solve this, and you will be getting Z11 actual. Okay, similarly, you'll be moving towards the next one, that is Z12. So Z12, the same formula you have to apply, and you will be getting some value. Okay, this value will be entirely different from this 4 cross 4 matrix. Okay, this value will be entirely different from your 4 cross 4 matrix, since we are making use of this Cron's reduction formula. Okay. So moving to Z13, the same thing, you can just put the formula and just see. And over here is Z21. So as per the matrix, your Z12 value over here will be same as that of Z21. So you can directly write it. So is it 1 2 actually we have already found out, that is over here. As per this, so the Z21 will be like this. Okay. So next you have to move towards Z22 followed by Z23. Okay, directly you can just put the formula, and then Z31 and over here also Z31 is same as that of Z13, and Z32 is same as that of Z23. And finally it is off to Z33. Okay, now what happens, you just see you are substituting those values in a matrix format. What happens, the matrix is reduced. So now it is a 3 cross 3 matrix. Okay, the matrix which was a 4 cross 4 like this, okay, has been reduced to this format by making use of your Cron's reduction formula. Okay, it's simple form, you can easily solve it. Okay, so after this it's up to your step 5. Step 5 is, as he said, you will be attaching another one impedance to your uh, third bus, and the other things will be as existing system, and you'll be adding this J0.3 to your reference bus. Okay, so this step 5, uh, uh, you guys try it out. Okay, so here also you can clearly see that as per the step 5, if you are adding it, you will be getting again a 4 cross 4 matrix. Okay, you will be again getting a 4 cross 4 matrix. You will be adding with respect to this matrix, adding the elements with respect to this matrix, and you will again get a 4 cross 4 matrix, and again you have to move towards your node elimination method. Okay, after putting the node elimination method, you will be getting the final answer in a 3 cross 3 matrix. Okay, so you guys just do this. Okay, you guys just do this problem, and Saturday you just report to me about this step. Okay, so tomorrow for you it is model. So during Saturday period, you just report it. Okay.